Assalamualaikum warahmatullahi wabarakatuh. So today, our team, which consists of Nurin Vanessa, Anis Fazlina, Sharon Nabil, and I, will present more regarding the operation of cyclic devices theory of real-life equipment. As a major producer of home appliances products, for us, engineering is everything. We are fiercely dedicated to transform people's lives with our radical ideas by solving the problems others ignore. Just as we constantly strive to identify the problems of the future, we are committed to inspire and train the engineers who will solve them. So, as requested by the Sales Engineering Department, our team will elaborate more on the operation of cyclic devices, which applying the concept of the second law of thermodynamics.
So now let's talk about the thermal energy reservoir. As we all know, thermal energy reservoir is body with relatively large thermal masses. So this reservoir can act as source or sink of heat, where source they will supply energy while sink will absorb energy, and it can supply and absorb, just like I said, finite amounts of heat without undergoing any changes in temperature. So, for example, in geophysical processes such as the weather, normally the lakes of oceans and rivers often function as thermal energy reservoir. As for atmospheric science, the large air masses in the atmosphere often function as thermal energy reservoir. So now let's move on to reversible and irreversible processes. So what are reversible and irreversible processes? A reversible process is one in which both the system and its environment can return to exactly the states they were in by following the reverse path. For example, an ideal gas expanding into vacuum twice its volume, we can easily just use a piston to push it back into it to restore its temperature and pressure by removing some heat from the gas. But the problem is that we unable to um, avoid like changing something to its surrounding. For example, like since we are gonna remove some heat from the gas, we cannot avoid like removing the heat to the surrounding. And for irreversible process, um, it's a process in which the system and its environment cannot return together to exactly the states that they were in. For example, if two objects in thermal contact, one in which the temperature is higher than the other one, spontaneous heat flow will occur where the one with higher temperature will flow into the lower temperature. So now I will let the next presenter continue.
One of the most important things we can do with heat is to use it to do work for us. A heat engine does exactly this. It makes use of the properties of thermodynamics to transform heat into work. Gasoline and diesel engines, jet engines, and steam turbines that generate electricity are all examples of heat engines. A cyclical process brings a system, such as the gas in a cylinder, back to its original state at the end of every cycle. All heat engines use cyclical processes. And the most important thing is, heat engines do work by using the part of energy transferred by heat from some source. Heat pumps, air conditioner, and refrigerators utilize heat transfer of energy from low to high temperatures, which is the opposite of what heat engines do. The purpose of a pump or a heat pump is to transfer energy by heat to a warm environment, such as a home in the winter. Air conditioners and refrigerators are designed to cool substances by transferring energy by heat out of a cool environment to a warmer one. In the case of a refrigerator, a heat is moved out inside of the fridge into the surrounding room. For an air conditioner, heat is transferred outdoor from the inside of home. Heat pumps are also often used in a reverse setting to cool rooms in summer. Heat pumps transfer heat by circulating a substance called refrigerant through a cycle of evaporation and condensation. A compressor pumps the refrigerant between two heat exchanger coils. In one coil, the refrigerant is evaporated at low temperature and absorbs heat from its surrounding. The refrigerant is then compressed en route to the other coil, where it condenses at high pressure. At this point, it releases the heat it absorbed earlier in the cycle. One of the major examples of heat pump is refrigerators, but refrigerators operate in the cooling mode.
So we are moving on to the basic principles of second law of thermodynamics. So theory of the second law of thermodynamics established the concept of entropy as a physical property of a thermosystem. Entropy predicts the direction of spontaneous processes and determines whether they are irreversible or impossible despite obeying the requirement of conservation of energy, which is established in the first law of thermodynamics. So the second law may be formulated by the observation that the entropy of isolated systems left to spontaneous evolution cannot decrease, as they always arrive at a state of thermodynamic equilibrium, where the entropy is highest. If the all processes in the system are reversible, so entropy is constant. The second law of thermodynamics provides the necessary means to determine the quality as well as the degree of degradation of energy during a process. More of high temperature energy can be converted to work, and thus it has a higher quality than the same amount of energy at a lower temperature. The second law of thermodynamics is also used in determining the theoretical limits for the performance of commonly used engineering systems, such as heat engines and refrigerators, as well as predicting the degree of completion of chemical reaction. So the basic principles of heat pump. So the heat pump has same cycle as refrigerator but differ in the objective. So the coefficient of performance is shown, desired output over the required input, or also can be expressed the QH over W net, which can also be expressed as QH divided by QH minus QL, or 1 divided 1 minus QL over QH. So this is comparison of equation of refrigerator and heat pump is coefficient of performance of heat pump equal to coefficient of performance refrigerator plus 1.
The objective of a heat pump is to maintain a heated space at a high temperature. This is accomplished by absorbing heat from a low temperature source such as well water or cool outside air in winter and supplying this heat to the high temperature medium such as a house. The operation principle of heat pump is transfer heat by circulating a substance called a refrigerant through a cycle of evaporation and condensation. The heat pump compresses the refrigerant to make it hotter on the side to be warm and releases the pressure at the side where heat is absorbed. The working fluid in its gaseous state is pressurized and circulated through the system by a compressor. On the discharge side of the compressor, the hot and highly pressurized vapor is cooled in a condenser until it condenses into a high pressure. The condensed refrigerant then passes through an expansion valve. The low-pressure liquid refrigerant then enters the evaporator, in which the fluid absorbs heat and boils. The refrigerant then returns to the compressor and the cycle is repeated. The example principle of heat pump is heating in winter and cooling and dehumidifying in summer. A heat pump can supply heat to a house even on a cold winter. That's all from me.